Understanding Archimedes Principle, presented by Christina Simmons and Bailey Beach. In our demonstration, 2 golf balls are dropped into a pool. Things you should know: both balls occupy the same volume. The first ball that was dropped was a practice golf ball, and the other is a standard size golf ball. They each have different densities. As you can see, the practice golf ball floats, and the standard size golf ball or white golf ball sunk to the bottom of Bailey's pool. Why? Because of the forces acting upon the objects, the weight of these items, and the varying amount of displacement that takes place when each object is dropped into the pool. Now, when it comes to the sinking or floating of an object, it is important to remember that any object in a fluid has 2 forces acting upon it: the weight of the object in the downward direction due to gravity, and the buoyant force, or the weight of the fluid displaced by an object, in the upward direction due to the fact that it's in a liquid. When the buoyant force is greater than the weight of the object will float or move upward. This was the case with our practice golf ball. The inverse is also true. When the buoyant force is less than the weight of the object will sink or move downward. This was the case with our standard golf ball. When the buoyant force, however, is equal to the weight of the object, or the force in the upward direction is equal to the force in the downward direction, that object will stay put and remain suspended. Before we dive into Archimedes' principle, let's explain this in terms of displacement. Now, the density of the balls ultimately determines whether or not these items will sink or float. When you put any object in water, that volume of the object displaces the same amount of volume of water. If the mass of an object is greater than the mass of the water displaced, it will sink. If the mass is less than the mass of the water displaced, it will float. Let's wrap up with Archimedes' principle as a whole. That first bullet, as you can see, is the equation. mF equals the mass of displaced fluid. In this case, it would be water minus the size of the ball equals the amount of water displaced by the ball. And that's how I was talking about the sphere of water. The density of this sphere of water is less than the density of a standard golf ball, so the golf ball will sink, whereas the density of the practice golf ball is less than that of water, and that is why it floats.